Hey everyone, welcome to Physics with Mr. Tarab, Zombie Apocalypse version. But you guys know I've been a zombie all along, or a comedian or something. But in all seriousness, I know we're going through some tough times right now, with everyone holed up at home for almost a month, and I know some of you may be concerned about your loved ones and whatnot. So anyway, what we're looking to do over the next 6 weeks is go over the basics of what we would have covered if we had been in class. And so basically the way this is going to work is in the email that I sent you guys, there's two links. One is to this video and one is to a resource page that has different resources to cover the material. So there's stuff from Mr. Wayne, there's Khan Academy videos, and there is textbook links. In addition, I'm going to go over a little bit of the basics in this video here with you today. So the way it's going to work is there's going to be 5 assignments that you're going to have to complete to successfully get credit for the class. Complete those assignments successfully, you'll get credit. And those assignments are posted on Schoology. One of them is due every Thursday for the next 5 weeks. And the last week, there's an optional assignment that Mr. Wayne is looking for some ideas for problems to solve, to set up for next year. So, but again, that's entirely optional. As far as how you turn these in, the best way to do it, I think, is to type out your work and your answers on a Google Doc and share it with me. Another thing is that you could do is you can actually print them out and scan them and send them to me, or you could take a picture of them and send them to me by email. Any of those ways work. If you want to do all of them like the first week and turn them in and be done with it, that works too. Again, you have to successfully complete them, so I'm going to look at them, and if they're good, I'll let you know it's good. If there's a problem, I'll probably send it back to you and say, hey, you need to look at this thing again. So I just want to go over very briefly the main ideas that are covered as far as the content, so you can come back whenever you feel like doing some learning. Okay, so we're going to be looking at the conservation of energy and the conservation of momentum. Conservation of energy, you may have heard of energy. There's, in the Khan Academy videos, kind of a circular definition of energy as the ability to do work, and work will impart energy. So in any case, I've often heard energy described as a quantity that just so happens to be conserved, and so it's very useful for analysis because it happens to be conserved. And the quantity that happens to be conserved is force acting over a distance. And so that's force times distance, so newtons times meters, and it has a unit called the joule. Now, we already looked at torque, where you also had the newton times the meter, but in the case of torque, we left it as newton meters, and here we could refer to it as joules. The reason that that works is because of the way that the numbers are multiplied together. So here we're looking at what we call a dot product, whereas with torque we were looking at a cross product. So now we're looking at force that's applied in the direction of the distance that we are moving. Therefore, if you have an object that you're lifting, then you can see how much force you're applying upward and how much distance you lifted it, and that's going to tell you what work you put into it. And that's going to turn out to be the potential energy that you've added to the object. And so the force is going to be mg, and that distance is going to be h, and so the formula for potential energy is mgh. Now, as I'm going through these formulas, you might want to pause the video every once in a while, as I'm doing as I'm filming this, and write things down. So if you're more of a visual learner, that's one way to do it. Again, there's lots of resources available through that resource link. But this is also, if you're more of an auditory learner, you can just kind of follow along by listening to me. If you're kinesthetic, you're a little bit out of luck because we're not going to be doing any labs. Okay, so we're looking at this potential energy as mgh, and kinetic energy is actually 1/2 mv squared. You may have seen that formula perhaps in a physical science class, I'm not really sure, but the reason it's squared is that force acting over a distance, you actually cover more distance as you are accelerating something due to a force if it's already moving faster. So say going from 10 miles an hour to 20 miles an hour, you're adding a lot more energy than just going from 0 to 10. And as one object gains energy, another object is going to be losing energy potentially, and that's what we call conservation of energy for a system. The reason for that is Newton's third law. So every action has an equal and opposite reaction, so if over some distance you're applying a force on one object, then over that same distance the other object force is being applied on it in basically opposite direction, so it's going to have, let's say, a negative total energy associated with that. Anyway, so basically we've got 1/2 mv squared as kinetic energy and mgh as potential energy, and what we essentially are doing is interchanging from one to the other. Another thing you could look at is energy as force times distance from its definition. So let's see what that looks like in terms of the problems you're going to have to solve. So looking at the first handout, there's two problems. The first one has two objects, and you're trying to set the condition where they each have the same amount of energy. And so essentially 1/2 mv squared for one object is going to be equal to 1/2 mv squared for the other object. You need to solve for the velocity of the second object, keeping in mind that the energy is going to be the same, and to be very careful about your unit conversions because the kilogram is the basic unit of mass. Now on the second question, 1/2 mv squared is going to equal the force times the distance, and you are going to be solving for the velocity of the first object. And you can actually solve that problem using what we already know about dynamics and kinematics, but energy can sometimes be an easier way to solve it. On the second question, you have a conservation of energy problem. So you're starting out with some amount of potential energy and some amount of kinetic energy because the object has a velocity and a height to start with. And then at the end, it just has a height, right? It comes to a velocity 0, it comes to a stop at its highest point. And so what you want to do is you get all the energy from the initial conditions, and then you put that in the end, that equals mgh at the end. You know m, you know g, you solve for h.